Imagine waking up one morning in Paris and seeing minus 30 degrees Celsius on the thermometer. In Germany, wild reindeer wandering through frozen forests. In London, the Thames is turned into a natural ice skating rink. Sounds like the plot of an apocalyptic movie, doesn't it? But this reality might be closer than we think, and it all depends on a massive, invisible river flowing beneath the waters of the Atlantic that very few people know about. This is the secret behind Europe's climate. The Gulf Stream, a force of nature that carries tropical heat from the Caribbean to Europe's shores. Think of it as a natural heating system that makes the European continent livable. Without it, cities like Paris, London, and Amsterdam would have the same harsh climate as Alaska or northern Canada. But something worrying is happening to this natural thermostat of the planet, and not enough people are paying attention. Renowned scientists have detected changes in what's called the Atlantic Meridional Overturning Circulation, or AMOC, a complex system of ocean currents that includes the Gulf Stream. And that's what we're going to explore today. How this delicate system works, why it's at risk, and what could happen if it actually collapses. But the Gulf Stream doesn't work alone. It's part of a larger system of ocean currents that redistributes heat across various parts of the planet. The AMOC functions like a giant ocean conveyor belt. It carries warm, salty water northward, where it cools, sinks, and flows back south in deep waters. This cycle not only keeps Europe warm, but also regulates the global climate, influencing rainfall patterns, temperatures, and even ocean productivity. However, this delicate system is under threat. Global warming is melting polar ice caps, dumping fresh water into the North Atlantic. This fresh water dilutes the ocean salinity, weakening the sinking process that drives the AMOC. Recent studies show that the AMOC is now at its weakest point in over 1,000 years, and the risk of a total collapse is real. If that happens, the Europe we know would change dramatically. Imagine London with temperatures typical of Arctic Canada, French vineyards buried under ice, and Mediterranean olive groves turned into frozen landscapes. Without the warmth brought by the Gulf Stream, temperatures in Western Europe would plummet. Cities like Dublin and Oslo, which currently enjoy mild winters, would face intense snowstorms and prolonged frosts, with thermometers dropping up to 10 degrees Celsius below current averages. This wouldn't just reshape Europe's landscape, but would also demand drastic adaptations in infrastructure and daily life. Agriculture would be one of the first victims of this new climate. Crops like wheat, barley, and tropical fruits, which rely on long-growing seasons and mild temperatures, would suffer from unpredictable frosts and shorter growing periods. Countries like France, Germany, and the United Kingdom, major agricultural producers, would see their harvest decline drastically. In southern Europe, regions like Spain and Italy, known for their olive groves and vineyards, would face more frequent droughts as rainfall patterns shift. Beyond agriculture, Europe's biodiversity would be deeply affected. Marine species that depend on the warm waters of the Gulf Stream for migration and reproduction would face extinction. On land, entire ecosystems could collapse, with Mediterranean species disappearing as the climate becomes more hostile. Temperate forests like those in the UK and Germany could be replaced by colder, more barren landscapes resembling tundra. The collapse of the AMOC in the Gulf Stream would transform Europe into a colder, harsher continent, with profound impacts on agriculture, biodiversity, and people's daily lives. But the effects wouldn't be limited to Europe. It would be a global catastrophe. These ocean systems are like the heart of the planet's climate, pumping heat and regulating weather patterns around the world. If they stop, the consequences will be felt everywhere, from New York to Mumbai, from the Arctic to the tropics. One of the immediate effects would be a rise in sea levels along the eastern coast of the United States. The Gulf Stream helps pull water away from the coast, but if it weakens, that effect would diminish, leading to a significant rise in sea levels. Cities like New York, Miami, and Boston would face more frequent and severe coastal flooding. threatening infrastructure, economies, and millions of lives. Additionally, storms and hurricanes could become more intense, fueled by the warmer Atlantic waters. In the tropics, the collapse of the AMOC could destabilize monsoon patterns, which are critical for agriculture in regions like South Asia and West Africa. Without the heat redistribution provided by the AMOC, monsoons could become erratic, causing prolonged droughts in some areas and torrential rains in others. This would have a devastating impact on food and water security for millions of people, exacerbating conflicts and triggering mass migrations. The Arctic would also be deeply affected. The AMOC helps transport heat northward, moderating temperatures in the region. If the system collapses, the Arctic could experience temporary cooling, but the overall effects of global warming would continue melting polar ice caps. This paradox could create a chaotic scenario with unpredictable impacts on Arctic ecosystems and the communities that rely on them. The collapse of the AMOC in the Gulf Stream would have global repercussions, from rising sea levels to disrupted monsoon patterns and accelerated changes in the Arctic. But how do we get to this point? Global warming, driven by carbon emissions, is disrupting the delicate balance of the oceans. But how exactly is this happening? And why are these systems, which have existed for millennia, now at risk of collapse? Let's dive into the causes behind this crisis. The main driver of AMOC weakening is the accelerated melting of polar ice caps, particularly in Greenland. As the ice melts, massive amounts of fresh water are dumped into the North Atlantic. This fresh water dilutes the salinity of seawater, making it less dense and preventing it from sinking, a crucial process for the AMOC's functioning. Without this sinking, the global ocean conveyor belt loses strength, and the transport of heat northward is drastically reduced. Global warming is also heating the surface of the oceans, creating a warmer layer that disrupts the vertical mixing of waters. This phenomenon, known as ocean stratification, interferes with the AMOC's natural cycle, which relies on the exchange of heat between surface and deep waters. Additionally, rising global temperatures are altering wind patterns, which also play a crucial role in ocean circulation. Another contributing factor to the weakening of the AMOC is deforestation and changes in land use. Forests, especially tropical ones, help regulate the global climate by absorbing carbon dioxide and releasing moisture into the atmosphere. The destruction of these forests disrupts the natural carbon and water cycles, exacerbating global warming and in turn accelerating polar ice melt. Faced with the threat of the AMOC and Gulf Stream collapsing, one crucial question arises. What can we do to prevent this catastrophe? The good news is that there's still time to act, but the solutions require urgent and profound changes. From reducing carbon emissions to protecting ocean ecosystems, let's explore the strategies that can save these vital systems and ensure a more stable future for the planet. The first and most urgent solution is a drastic reduction in carbon emissions. Global warming is the primary driver of AMOC weakening, and to halt this process, we need to reduce the amount of greenhouse gases in the atmosphere. This means accelerating the transition to renewable energy sources like solar, wind, and hydropower, as well as promoting energy efficiency across all sectors. International agreements, such as the Paris Agreement, are critical, but it's essential for countries to meet their goals and raise their ambitions. Another key solution is protecting and restoring ocean ecosystems. Oceans are major carbon sinks, but they are under pressure from pollution, overfishing, and acidification. Establishing marine protected areas, reducing plastic pollution, and promoting sustainable fishing practices can help strengthen the resilience of our oceans. Additionally, restoring mangroves, coral reefs, and other coastal zones can enhance the ocean's ability to absorb carbon and regulate the climate. Technological innovation also has a crucial role to play. Geoengineering projects, such as carbon capture and storage, can help remove excess CO2 from the atmosphere. Advanced ocean monitoring research can provide precise data on the state of the AMOC and Gulf Stream, enabling quicker and more effective responses to critical changes. However, these technologies must be implemented cautiously, considering potential side effects. Preventing the collapse of the AMOC and the Gulf Stream requires a combination of emission reductions, ocean protection, and technological innovation. But these solutions will only be effective if implemented globally and in a coordinated manner. The weakening of the AMOC and Gulf Stream is a global issue that demands global solutions. No single country can tackle this crisis alone. Robust international cooperation and effective public policies are essential. But how can governments, international organizations, and civil society work together to prevent a climate catastrophe? Let's explore the crucial role of diplomacy, international agreements, and national policies in this effort. International cooperation is essential to address climate challenges on a global scale. Agreements like the Paris Agreement are fundamental, but must be strengthened with more ambitious targets and stricter enforcement mechanisms. Developed nations, which have historically emitted the most carbon, have a responsibility to lead this transition by providing funding and technology to developing countries. Furthermore, forums like COP, Conference of the Parties, must become platforms for concrete action, not just theoretical discussions. National public policies also play a crucial role. Governments need to implement measures such as carbon taxes, subsidies for renewable energy, and stricter regulations for polluting industries. Public education and awareness are equally important. Campaigns that explain the risks of an AMOC collapse and the importance of climate action can mobilize citizens to push for change and adopt more sustainable habits. Moreover, collaboration between science and policy is vital. Scientists and researchers must work closely with governments to provide accurate data and evidence-based recommendations. Ocean monitoring programs, such as Argo and GeoS Global Ocean Observing System, need more investment to ensure we have up-to-date information about the state of the AMOC and the Gulf Stream. This constant monitoring is not just a modern concern. History shows us how profoundly these ocean systems can impact entire civilizations. One of the most fascinating stories about the Gulf Stream comes from the Vikings. Historical records suggest that they managed to colonize Greenland during a period when the current was particularly strong, creating a milder climate. When the system weakened during the Little Ice Age, their settlements collapsed, a warning from the past about how changes in ocean currents can reshape entire civilizations. Ocean currents also directly impact marine life in surprising ways. Humpback whales, for instance, navigate the Gulf Stream during their migrations, using these natural highways to conserve energy. Certain species of sea turtles rely on these currents to carry their hatchlings to feeding areas, and disruptions to these flows could disorient entire generations of these ancient reptiles. A less discussed aspect is how the AMOC even influences our culture. London's famous fogs, which inspired writers like Charles Dickens and Arthur Conan Doyle, are partially the result of the interaction between the warm air from the Gulf Stream and the cold air from the continent. These unique weather conditions shaped not only literature, but also European architecture and social customs. There's also a fascinating connection between ocean currents and ancient trade routes. Portuguese and Spanish navigators in the 15th century discovered they could use the Gulf Stream to speed up their voyages across the Atlantic. This knowledge revolutionized maritime trade and, ironically, contributed to the Industrial Revolution, which now threatens the very system that made these voyages possible. Throughout this video, We've seen how the AMOC and the Gulf Stream are the true arteries of our planet, and how their collapse could trigger devastating changes. But not all hope is lost. The same science that warns us of these risks also shows us ways to avoid them. We have the tools and knowledge we need, from clean energy technologies to ocean protection methods. What we need now is decisive action. Governments, businesses, and citizens must work together because this isn't a battle we can win alone. Time is short, but history shows us that we're capable of overcoming great challenges when we come together. Every action matters. Every choice counts. The AMOC and the Gulf Stream are more than ocean systems. They're a reminder that our planet is one, and its future is in our hands. If you enjoyed this video and want to learn more about geopolitics, leave a like, subscribe to the channel, and share it with your friends.